Imagine writing a single line of code, hitting execute, and then having to wait, I don't know, 30 entire days just to see if it actually worked.
Oh, that sounds awful.
Right. I mean, for a software developer who is used to getting instant feedback in like milliseconds, that sounds like absolute torture.
Yeah, definitely.
But what if that code isn't digital at all? What if it's Brazilian Snapdragon?
Now that is a pivot.
Welcome to the deep dive.
Yeah.
Because today we're looking at a really highly unusual source for you. It's a blog post from March 21st, 2026.
Yeah, hosted on a site called kianmeng.org.
Exactly. And the author, who goes by Ang, describes himself as an old software plumber.
I love that phrase.
It's great. And the specific document we're unpacking today is titled Notes on Gardening, Part 842, on propagating Brazilian Snapdragon.
Which, I mean, is just an incredible title for the number alone, Part 842.
I know, right?
And the mission for our deep dive today is to really look at the collision of two completely different worlds. We're going to explore what happens when an open source, highly technical mind takes rigorous software debugging principles and applies them to the slow, messy, completely unpredictable organic world of nature.
Which is quite the task.
It is. And to really understand how this author processes reality, we have to start with the specific physical data he's observing in his garden, and then we can, zoom out to the broader architecture of his mind.
Okay, let's unpack this, starting with the physical experiment itself.
Let's do it.
So Ang is working with two specimens of the Brazilian Snapdragon. The scientific name is Otacanthus caeruleus, which produces these beautiful blue flowers.
Really striking.
Yeah. And he notes that he's had these mature plants for many moons after finding them in a nursery. And of course, because of the way his mind works, he actually documented that original purchase way back in part 559 of his gardening notes.
Which is wild. He essentially treats the original mature plants as like version 1.0 of a software release.
Oh, that's a good way to look at it.
Right. He has the initial documentation from when they were first installed in his garden, and now he is trying to create a fork of that original repository. He's propagating them.
Taking cuttings from the established plants, right?
Yeah.
And putting them into regular plotting mix to grow brand new clones.
Exactly. And the underlying biological mechanism here is actually fascinating when you view it through that technical lens.
How so?
Well, when Ang takes a cutting, he is bearing a node, the little bump on the stem where leaves usually grow under the soil.
Right.
And in the dark, moist environment of the potting mix, the undifferentiated cells at that node switch their programming.
Oh, wow.
Yeah, instead of executing the command to grow a leaf, the environmental variables force them to execute a command to grow root tissue.
That is wild. But the primary observation Ang makes in his notes is about the timeline of that biological programming, right? Because it is incredibly slow.
Painfully slow.
Yeah. He documents that it takes over a month for the plant to fully root through those nodes in the potting mix. I mean, for a software engineer, propagation in soil is exactly like running a massive background process on a computer.
But one without a user interface.
Exactly. You don't get a loading bar. You can't see the root cells dividing under the soil.
Right.
You just initiate the command, walk away, and wait a whole month for the invisible progress bar to eventually hit 100%.
Which, you have to admit, forces a radical context switch for a technical mind.
Oh, for sure.
Someone used to writing a line of code and instantly knowing if it threw an error is deliberately engaging in an exercise of blind waiting.
Because if he checks it, he ruins it.
Exactly. He can't dig up the cutting every day to check on the root development, or he'd introduce fatal friction. He'd kill it.
Right.
So he just has to trust the biological compilation process. He isn't trying to force the plant to move at the speed of software. He's adapting his mind to move at the speed of the plant.
I really want you, the listener, to actually think about that for a second. Consider the last time you committed to a slow, month-long process where you received zero instant gratification along the way.
It's hard to even imagine these days.
It is. In our hyper-connected digital age, waiting 30 days to see if a simple experiment even worked feels almost radical. But it does work.
It does.
Ang notes the experiment yields good results, and the new cutting is now officially, in his words, root-bound, meaning the new roots have completely filled the small starter pot.
Right.
He also briefly mentions that propagating the cuttings in water is supposedly possible, though he hasn't tested that specific variable himself yet.
And successfully navigating that month-long wait brings us to a really fascinating pivot in his notes.
Yeah.
Because while the new cutting the fork of the project is thriving and becoming root-bound, The original mature plants, the source code, are actively failing.
Let's look closely at those systemic failures, because success in one area of a project almost always highlights degrading performance in another, doesn't it?
Oh, always.
So Eng notes that his mature snapdragons are getting leggy. The stems are stretching out awkwardly, and worse, they are shedding their bottom leaves.
Yeah.
And this degradation is happening despite the plants being placed in the full tropical sun, which they usually love.
Right. And here is where we see the software plumber's mind diagnose a biological bug.
Yes.
He doesn't just look at the garden and say, oh, my plant looks sad.
Right, he's much more analytical than that.
Exactly. He looks at the specific outputs, the symptoms. He observes that the shedding bottom leaves are turning brown before they drop.
Right.
And he then correlates that symptom to potential environmental causes, like low humidity or a lack of moisture from inconsistent watering.
Yeah, he specifically notes that this inconsistent watering is a real struggle under a recent heat wave. But let me push back on this meticulous documentation for a second.
Okay, sure.
I was reading this and thinking, well, if this guy is literally writing his 842nd note on gardening, how does he let his mature plants starve or suffer from inconsistent watering?
That's a fair point.
Doesn't a failing plant kind of prove that no matter how much you document your garden, nature always throws a wrench in the gears and ruins your perfect system?
It's a great question, but looking at it through the lens of system design explains that contradiction perfectly.
Okay, how so?
Think about it. In a closed software loop, the variables are entirely controlled by the programmer. You dictate the memory, the processing power, the inputs.
Right.
But a garden is an open system.
Yeah.
When you introduce a massive, unpredictable external variable, like a sudden tropical heat wave, it breaks the existing parameters.
Ah, I see.
The watering schedule that worked perfectly for his first 841 notes suddenly isn't mathematically sufficient to keep up with the new evaporation rate.
So the environment changed the rules of the program without warning him.
Exactly. And notice how he reacts to it. He doesn't panic, and more importantly, he doesn't internalize the failure.
Which is what most of us do.
Right. For a lot of casual gardeners, a dying plant induces guilt. We think, oh, I have a black thumb, I failed. Eng depersonalizes the failure completely. He reads the plant exactly like a developer reading a server error log.
Oh, that's such a good way to frame it.
Right. The server crashed, meaning the plant is leggy and brown. Why? He identifies multiple potential points of failure.
Okay.
Point of failure 1, ambient humidity dropped due to the heat wave. Point of failure 2, the manual watering schedule couldn't keep up with the new evaporation rate.
Makes sense.
And then he hypothesizes a completely different compounding variable regarding the roots.
Right. He theorizes that it's highly possible the mature plant is root-bound, just like the young cutting, and it's basically starving for nutrients.
And the biological mechanism here aligns perfectly with computer hardware. A plant running out of nutrients in a small pot is exactly like a server running out of random access memory, or RAM.
Wait, really? How does that work?
Well, when a server is overloaded and runs out of memory, it doesn't just immediately shut down.
It doesn't.
No, it starts selectively killing off low-priority background applications to keep the core operating system from crashing.
Oh, wow. That explains the specific symptom of the bottom leaves.
Yes.
The plant is rationing its limited resources.
Precisely. The Snapdragon is desperately trying to survive the heat wave with limited water and a root system that has run out of physical space. So it acts like an overloaded server.
That is fascinating.
It selectively kills off the older, lower leaves, turning them brown and shedding them, so it can funnel every drop of available moisture to protect the vital new growth at the crown of the plant.
So the hardware of the pot is bottlenecking the biological software.
Exactly.
So what does this all mean? I mean, he's observed the symptoms, he's read the error logs, and he understands the underlying mechanisms of why the leaves are browning.
Right.
Now he has to push the next update, because Eng doesn't just passively document a failure, he uses it to iterate.
Always iterating.
Yeah. At the end of his post, he outlines 3 very clear future plans. Number 1, transplant the root-bound cutting into a bigger pot. Number 2, experiment with that untested water propagation method he read about. And number 3, give the starving and mature plants a much-needed fertilizer boost.
If we connect this to the bigger picture, he's essentially rolling out version 2.0 of his garden through a series of isolated patches.
Oh, I like that.
Giving the mature plant a fertilizer boost is an emergency bug fix applied to the legacy system.
Right.
Transplanting the new cutting addresses the hardware bottleneck issue before it causes a system crash. And experimenting with water propagation is basically launching a beta test for a brand new feature.
It's the scientific method, but accelerated by a developer's mindset.
Exactly.
He takes the data from both the success of the cutting and the failure of the parent plant and actively designs his next set of sprints.
Yeah.
I mean, a normal gardener might just buy a bigger pot, throw some fertilizer on the dirt, and move on with their weekend.
If they even bother to do that.
True. But Ang logs this diagnostic process as part 842, which forces us to ask a really important question. What exactly were the other 841 notes?
Oh, this is the best part.
We have to zoom out and look at the massive, staggering repository of knowledge that this single Snapdragon post lives within, because it reveals the architecture of a truly obsessive mind.
The scale of the archive on qianmeng.org it's difficult to even grasp until you look at the raw numbers.
It's unbelievable.
If you look at the historical data provided in the source, he published 730 posts in the year 2025.
Wow.
He published 732 posts in 2024. That is an average of 2 incredibly detailed, highly observational essays every single day, year after year, without fail.
Here's where it gets really interesting, though. It isn't just the volume, right? It's the extreme cognitive whiplash of his topics.
Oh, yeah.
I looked at the categorization of his output for just the month of March 2026 alone. Remember, the Snapdragon post is part 842 of just the gardening notes.
Just the gardening.
Yeah. But in that exact same month, he is juggling an unbelievable number of cross-disciplinary subjects. He's publishing notes on Haskell programming up to part 88.
Which requires a completely different type of thinking than gardening.
Totally.
Haskell is a purely functional programming language. It is highly abstract, strictly mathematical, and it relies on absolute, predictable logic.
And right after writing about pure mathematical logic, he switches to fish keeping, which he is on part 213 of, where he is actively documenting the spawning process of betta fish.
Right.
That is as messy, biological, and hormonal as a topic can get.
Literally the opposite of Haskell.
Exactly. Then he pivots to photography. Then he's writing about dieting, specifically analyzing a highly purified lipid supplement called icosapent.
Okay.
Then he dives deep into networking, analyzing the MAC addresses of Wi-Fi 7 hardware. And he is publishing 60 to 90 of these cross-disciplinary posts a month.
It's wild how a single human brain processes that much context switching. I mean, from optimizing abstract Elixir or Haskell code to breeding tropical fish to noticing the subtle browning on the bottom leaves of a Snapdragon.
Right.
It all comes back to his self-described identity. He calls himself an old software plumber who tinkers with floss.
Floss. That stands for free, Libre, and open source software.
Exactly. And you can see that ethos reflected in the sidebar of his blog.
Yeah, he actively supports organizations dedicated to the democratization of knowledge and digital rights, like the Electronic Frontier Foundation, the Free Software Foundation, the Tor Project, and Wikipedia.
Understanding the concept of Libra in open source software is the skeleton key to understanding this entire document.
How so?
Well, in the floss community, free doesn't just mean free of charge. It means freedom.
Okay.
The freedom to study how a program works, the freedom to change it, and the freedom to distribute your modifications.
Right, that makes sense.
But that system only works if developers practice radical transparency. They have to publicly share their pristine code, but they also have to publicly log their messy errors, their crashed servers, and their bug fixes.
They show their broken work so that someone else doesn't have to struggle through the exact same mistake.
Exactly. Ang isn't just a fan of open source software. He is literally open sourcing his life.
Oh, wow.
He is applying that exact same philosophical framework to his daily existence.
He is publicly logging his life's source code.
Yes. Whether it's a Haskell programming compilation error or a tropical heat wave killing a potted plant, he views all of it as data that belongs to the broader community.
Right.
He's putting it out there so that someone, somewhere, trying to grow a Brazilian Snapdragon in the tropics can search the web, find part 842 and realize, oh, my plant isn't dying of some mysterious incurable disease.
It's just rationing resources like a server running out of RAM.
Exactly. It needs more humidity and a bigger pot. He's saving a stranger time by sharing his own friction.
And it's the ultimate weapon against repeating your own mistakes, too. Writing it down forces you to articulate the problem clearly.
Oh, definitely.
And as any good programmer will tell you, a problem clearly stated is a problem half solved.
Very true.
I really want you, listening to this right now, to imagine what that level of documentation would look like in your own life. Imagine how much clearer your own hobbies, your professional skills, or even your daily habits might be if you documented your learnings with the same rigorous, cross-disciplinary curiosity as Aang.
It would be transformative.
What if you kept an open-source log of your own mistakes and fixes? Doing it twice a day is an extreme undertaking, sure, but the clarity it must bring to his chaotic, multidisciplinary life is undeniable.
It illustrates that the specific subject matter almost doesn't matter.
Right.
Whether you are writing a complex function in Haskell code, trying to figure out why your Wi-Fi 7 network is dropping data packets, or diagnosing why a blue flower is shedding leaves during a heat wave.
The underlying skill is exactly the same.
Yes, it requires patient observation, the ability to isolate and identify variables, a refusal to take failure personally, and the willingness to share what you learn with the world.
It really is a fascinating way to interact with the world around you. Not as a series of random, frustrating events that just happen to you, but as an endlessly complex system waiting to be understood, documented, and gently improved upon.
Beautifully put.
Which brings us to the end of today's deep dive. We started by looking at a slow-rooting Brazilian Snapdragon in a tiny pot of soil, and we ended up exploring how a software engineer's open-source mindset can turn a simple backyard garden into a meticulously documented laboratory for continuous learning.
And that leaves us with one final thought to ponder.
Yeah.
Aang discovered that his mature Snapdragon was struggling, shedding its leaves and browning because it was root-bound.
Right.
It was trapped in a container that had simply become too small for its growth. It had maximized its current environment, and its physical hardware was bottlenecking its potential.
So if you applied Aang's meticulous diagnostic logs to your own life right now, what would your error log say? In what areas of your career, your creative pursuits, or your intellectual curiosity might you discover that you are currently root-bound? And more importantly, what transplanting do you need to do today to ensure you have the space to keep growing?